This is going to be a slightly different talk than the one I originally put in the abstract. I was going to talk about a Carto dashboard for distributed statistical data and was hoping to show you this thing working and everything. But as it goes in the academic world, sometimes funding falls through, so we didn't get as far with the actual Carto dashboard and are left at a somewhat earlier stage than I had hoped. So to still give some flesh to my presentation, I also added a little reminiscing about coding in cartography, because this was actually, this project that I will be talking about was more or less my first entry into actually creating maps by code, fully by programming them. And this for a cartographer like me was a bit of a daunting thing, so this is also the story about how I learned to stop worrying and love coding in cartography. This is a Dr. Strangelove quote, actually, of course. So, I've been in cartography for quite a long time. I always call myself a cartographer because that was my training. And when I started in cartography in the late 80s, being trained in that, my tools were these. I don't know if you recognize them even. This is what we call a road ring pen, which was an ink pen for drawing equal width lines. And these are things like rulers and so on, and rub-off letters and things like that. And that was how we were trained to make our maps. Actually, this was also how I found out that I might not be a good cartographer. At least I was fearing that, because I was not very good at working with the road ring pen and these tools. I had nice ideas, I thought, about cartography, but the actual drawing of the maps was difficult. I was not that skilled in that, or as talented maybe. But luckily I was in an institute where they trained cartography as a communication skill. It was about teaching how to tell your message in maps. That was the basics. So the tools were always presented as well. This is the tools we have at the moment. And in the meantime, my tools are quite different. They look now like this. So I use WebStorm quite a lot for creating web pages, HTML5 pages included with HTML with SVG included. So I actually code some of my maps. And this was a journey, of course, through time to learn to use that other tool. The reason why those tools have become popular is because they have become much more powerful, much more potent. Computers first gave me this. The first map I ever made on a computer was using a mainline computer, or a mainframe computer program called SciMap. Hands up if for those who ever used SciMap. Well, this is a map actually of 1965. I'm not that old, but at my institute we were not that forward. So by the time I was exposed to computers the first time in I think 1984, that program was actually still used, and it used a line printer to actually make the maps. Well, that's not very nice, of course. It's not very satisfying for a cartographer to get this kind of output. But by now, of course, the tool of computer cartography has been improved quite a lot. So this is, again, with the washed out image, not so good to see. This is the New York City Henge by Andrew Hill, which is actually a very nice application where you can go and actively look at which times the sun setting or the sun rising aligns with the street pattern, in this case in Manhattan or in the greater New York area, I think. And then you can turn this thing around and you see which streets are actually aligned with the sunset. And you can actually do that interactively, and it actually also looks very nice, and it's very good to use as a tool also. So this is more like it. This is the kind of computing coded cartography that I actually would like to be able to make. So is coded cartography possible? That's basically the end. Can you make cartography by coding, and will it be cartography that actually can be considered good cartography? Well, I was very lucky yesterday when I walked into town to see this van. I actually photographed this yesterday. This is an oxymoron that you could really like. This is a guy who claims that he does ground-based aerial photography. So how can that be? Is coded cartography like that? Can you? Is it something that cannot be joined? That is an oxymoron, as they call that. Well, not so much, I think, because you have to think about: can a coder, a programmer, become a cartographer, or maybe should cartographers become coders, become programmers? Should I, as a cartographer, learn how to program? Which of those would be the best solution? You might even ask. If you think about that question, you're really thinking about the influence on cartography or the role in cartography of technology. Technology has, of course, always influenced, has always been influenced by technology in very many ways. Some people say that cartography goes ahead with, along with technology, but that might be going too far. Cartography is not equal, does not equal the technology. It has been influenced by it. The tools have been changed by it. One of the main big changes was, of course, when we changed from having to draw every map to being able to print them, and then later computers came, and you could actually disseminate your maps much more easy. Well, technology is not equal to cartography, but technology certainly influences the tools of the cartographer, and that's for sure. And we've seen that in many places, for example, in the publishing of maps, like I said, you used to have to make manuscript maps. Every map was its own unique version. Then print was invented, and we could actually disseminate them much more easily. Then digital means of doing that came, and the ultimate or the culmination of that at the moment is, of course, the World Wide Web, whereby we can share our map information very easily with very many people, and actually also very cheaply compared to the previous methods. The same is true for actual making of the maps. And at the moment, if you look at map making, drawing maps, creating maps, used to be done by hand, indeed, using these rotring pens that I showed you. And nowadays, I'm pretty sure quite the vast majority of cartographers draw their maps in digital ways, either using GIS software or illustration software. But they also now start to not only digitally draw them, but actually construct them digitally. And that is what I would call coding cartography, is constructing your map by digital means and not by drawing them, which is basically the same thing as you did before, but now with a different drawing pen, which is called Illustrator or Inkscape. That all doesn't matter, because cartography is just using those tools that you have at your disposal. And to me, my mind, and that was how I was trained back in the days, cartography is not so much about the tools that you actually make. You are not a cartographer because you can use a tool that renders a map. You are a cartographer because you are visualizing spatial data, and you are doing that with a certain intent. You're not just taking in the data like a very simple pipeline, and always at the end some map comes out. You're thinking about the goal, and of course cartography, as I said in my university, was taught as a communication science. So you have to think about your users. What kind of users are they? What kind of skills do they have? What kind of background do they have? What kind of information need do they have? What do you want to tell the user, etc. And we had these famous communication schedules or schemes, whereby you would have the reality going through the cartographer and its tools, and then going to the map, and the map would be read by the user, and everywhere along this communication there would be factors that influence the communication, so you would end up with a vision of reality that more or less overlapped the reality as you, as a cartographer, wanted to show. Now, this making a map with a certain intent can be done with any of the tools that we have at our disposal at the moment. And coded websites, making a code to create a website, is now one of them. And I can do things with that which I couldn't do before. But that doesn't mean to say that the sketch manuscript, as it were, would be obsolete now, because for some tools and for some cartographic intents, that is still the best tool available, or the best dissemination platform. Some examples, this one you will see later, of course, to greater extent. This is shown quite a lot by people. If they want to show, look, you can make interactive maps on the web, which are beautiful to look at, which are also very versatile, because they have all this interactivity, and they also bring across the message very well, because it's about learning how the wind and other climate factors are different and dynamic all over the globe. This is the wind map from Cameron Beccario. You will see it later. But you can also make this kinds of maps, and in some situations they are just as nice or much better, although they use very different tools. This is actually, I don't know if you can recognize it from there, these are the silhouettes of pumpkins that people put up at Halloween. You know, they carve out a pumpkin and put a light in it. And this is from a map by Dennis Wood, or an atlas by Dennis Wood called Everything Sings, a narrative atlas. And this is where he made, over very many years, maps of his own neighborhood, somewhere in a suburb in the United States, handcrafted maps of very unusual subjects. And this is a very strange map. It's not a traditional map. What does it tell you? It tells you something about how this neighborhood works and what happens in this neighborhood. Where are the streets where pumpkins are put up anyway? And what kind of pumpkins are they? And together with all the other maps that are in that particular atlas, they form a, they really let you, let's say, you learn how this neighborhood actually exists and how it works and what happens in that small community. And this has been drawn by hand and in various techniques, by pen and pencil and all kinds of other ways that he used to create such an atlas. And that really gives a very good, let's say, witness about this American suburb. And then that platform, that dissemination, those tools are appropriate for that particular job. But indeed, cartography, as a cartographer, I can use coding to do things that I couldn't do before. And let me break off quickly into an example. This is something I recently made for a, it's a bit small, for a magazine called Geography, so it's in Dutch, about the perception that students in the Netherlands, actually geography students, have of the distance from in this case, Amsterdam to capitals in Europe. And what so there was a geography professor there already when I started my first year, who gave all the first year students a list of capitals and asked them, please order them in the distance you think they are, how far they are from Amsterdam. And he saw this nice trend. Where you could see that in the southern directions, so this is the actual distance that they are, and they are perceived differently. And you could see that, for example, Lisbon was perceived much closer than it actually is. And for example, the strange case of Vienna, which was perceived much closer than Prague, actually is Praha. While in reality, of course, Praha is much closer to Amsterdam than Vienna. And you can show this in a map, in a static map, of course, but it wouldn't be as vivid as this when you can actually see the difference between the two. But even more, if you actually get the difference between the tests that they made in the 70s and the 80s, this same professor thought, well, at the moment he did this, he wrote an article. He said, well, it is very understandable because there's this Iron Curtain and people never go to Kiev and to Moscow, so they think it's much farther away than the places they do visit in the south. And then he thought of actually redoing the same test again after the wall had fallen in 2013, but still actually the same difference in perception could be seen. So you can see there's only a very small change in the perceived location of some of these places, and actually some of them, like Moscow, even seems now farther away than it used to be. You could couldn't make this very nicely into one map that brings across the same message if you only used, let's say, analog tools and not coding, because you can also do things like the linked views, which are, of course, very much known from GIS, but are also possible in these websites where you can actually see the changes also in a graph like this in the same way that they change here. Okay, that's for an example. Go back here. So then you have to start thinking about, okay, can I as a cartographer be a coder, or should I ask coders to become cartographers? Well, coders surely can be cartographers, and somebody who could engrave could also be a cartographer, because as I showed you earlier, cartography is about thinking about the message and making this spatial data visualization with a certain intent. Cartography in that sense is more like a state of mind than an actual science or skill in that sense. So a coder could be a good cartographer or a lousy cartographer, but it wouldn't be just because he's a coder. The other way around, can cartographers become coders? Well, of course, it's just a tool. So if you can manage to learn the tool, you should be able to use it. Just as you could become an engraver. I wasn't very good at that, as I told you, but some others might have been more successful. It's just another tool in that sense. So you have to then think about the cartographer having a sort of a new role. You are now providing the tools that implement the cartographic intent, actually. So you have to make sure that these tools actually do the cartographic ideas justice. Or you have to provide the cartographic knowledge for these tools to do that, because of course not always you are, as the cartographer, the one actually making the map. You could be in a team where other people do the coding, so you don't have to specifically know the coding. But you also have to think, and that was the next step that you I had to take, you also have to think of maps being now constructed not by you or by a tool that you use at the moment that you do that, but maps being constructed automatically. That's of course the reality that happens nowadays. There's not a team of persons at Google who all the time when a request comes in quickly make a map and give it to the people, not even by coding it on the spot. No, that is all done automatically by services, of course. We live in a different world whereby the maps are not created on demand piece by piece, but they are created on demand by services. And then I started to think about you should actually have code that things like a cartographer. So the code should actually have the behavior of the cartographer. I've put it here not as code that thinks like a cartographer or a map, but code that thinks like an atlas, and I have a reason for that. Because an atlas is in some cases more than just a map. And the reason why we started thinking about that is because I personally started using code in cartography when I got involved in the project in the Netherlands for the Dutch National Atlas. So the Dutch National Atlas, you can I've talked about that before, started out as printed atlases, and nowadays we try to keep it alive as an atlas that actually connects to the spatial data infrastructure, the services that are available in the Dutch, from the Dutch government. So we started to think about a national atlas, not a traditional one, but one that would fit in the current day and age. And then we started also thinking about, well, this means that the role of this cartographic program is not typically the one where you get some data, you think about what kind of map to make, you use your tools, either digital or analog or whatever, to create a map. Now this is going to be a service just like any of these other services in such a spatial data infrastructure. People go to the cadastral site to find out about the mortgage that is on a certain piece of land. They go to the municipal site to ask about their taxes, and they go to a mapping site, an atlas site, to find maps about the Netherlands. That's the idea anyway. What you then have to do is, of course, combine these two different worlds. The world of the spatial data infrastructures is this highly evolved computer science world of services and standards and clients and server software structures. And the Atlas world traditionally is about combining data with careful thought about which of the data to combine, how to combine them, are they combinable, should they have the same scale, the same generalization, the same symbology, etc. Which is not typical for a spatial data infrastructure. This is data that all complies to a standard, and therefore technically you can combine them, but there are little or no mechanisms in the current SDI technology to actually say things or have the software find out things about, is this actual data which should be combined, which can be combined, are the scales the same, are the generalization levels the same, etc., etc. So we wanted to think about how you could have this SDI being more behaving like an atlas, or in other words, have the atlas become a real part of such an SDI. And then you have to think about mapping in a web services environment, which at the moment is typically set up like this. People who have worked with map server and things like that, they know there's some data, there's a mapping service, or WMS, or one of these other things, and it has to go to a web browser where the map has to the user has to look at the map, and you have to set that up in some kind of a configuration, be it a .map file of map server or some other kind of configuration. And the cartographer can play a role there, of course, because he can be involved in setting up the service configuration, but it's for this particular mapping service only. And what you get if you really want the mapping to become part of the web map services, you have to think about how this could be more automatic and still maintain cartographic quality, as it were. So you could think of, and this is just one of the ideas that we are playing around in the research part of the department, you could think about these service configurations being made automatically by some kind of a compiler using some kind of formal map specification. But all of this will mean that there is a conceptual change needed in how mapping is typically done in these spatial data infrastructures nowadays, which is there are nodes in such an SDI, so there's maybe a node from the statistical service, there's maybe a node from the topographical service of the Netherlands, or from the tax office, and each of them might have their separate map services being set up in a certain way. And yes, in these map viewers, in these data portals, you can combine those maps, but there are the different separate maps that can be maybe overlaid or whatever, maybe some transparency added, but it's basically the same problem that you get if you want to overlay your data on top of an existing data service like Google or OpenStreetMap. You are stuck with what Google gives you, or OpenStreetMap, and you're stuck, you can influence your own map, but you'll just have to compromise in how the two work together. And what would be much nicer is if you could use the same data. You don't want to touch that, because the idea of an SDI is each of these institutes are responsible for their own data, and you don't use a map service out of these nodes, you use the data service, and you as the Atlas node are becoming another node in the SDI which combines data services into what I call here a data integration and mapping component, and get maps out of that. And then you have a chance to have this component be thinking about the cartographic questions like, are these two data services compatible? Do I even want to be able to combine them? If so, do I need to change the data? Do I need to generalize the data, aggregate the data, whatever? And then you could have a true integrated mapping of the data layers instead of this suboptimal combination of arbitrary map layers. And the architecture we have been creating for that in our testbed, it's very brief. I won't go into all the details here. It is that you have these nodes in the SDI. At the moment, for our testbed, we use Central Bureau of Statistics data and the Ministry of Environment natural data. These all we use the data services, which are actually, I should press this actually. The data services. So that's WFS standard usually within this Dutch system. They use the Inspire standards, so they have to use OGC standards like web feature services to get the data out. And we request our system requests those data as data services, so not maps, but just the raw data, preferably in GeoJSON, because that we can use that much more efficiently in our client. There's a middle layer too, but let me skip that one for now. At the end there's an Atlas viewer, we call it an Atlas viewer, which is basically D3 again. So D3 is not, has been popping up quite a lot here. Actually in 2010, in the Boston conference, I had my first workshop in D3. I think it was given by Mike Bostock himself, and that was already when I saw, oh, that's nice, so I want to use that. And there are good reasons why this is now at the moment a very popular JavaScript library for using HTML5 and SVG in a modern web platform. But it's just a solution. It's just a tool. We come back to the original introductory part. If you can use that tool, you could also use another tool, as long as that is the tool that you are familiar with and you can actually work with. You can get your results with. But in this case, it's a JavaScript JavaScript system that we use to create the GeoJSON out of the Atlas layers and create the actual Atlas maps. I will show you a quick demo a bit later. In between there is a middle layer. We call it the Atlas Utility Services and Base Data, and that is actually the part which is the Carto engine, the cartographic brain of the whole thing. Because in here we have metadata that basically is takes the place of the editorial board of an atlas. It tells the system, well, you could offer this kind of map in your atlas, and you should use those particular services, those particular data services. You can combine them. You have to maybe do something about them. Maybe you have to aggregate them. So we have an aggregator service that, for example, takes municipal data and aggregates it to the provincial level and that kind of things. We actually have some utility software like GML to GeoJSON proxy, because not all the services actually can deliver the data as GeoJSON. According to the standard, as the Inspire standard, they only have to do it as GML, and JSON is an optional. Luckily, most of them do this, so it doesn't have to be used all that much. And this system also has all kinds of Atlas base maps, for example, to give the whole thing how you call that, a joint look and feel. So the coastlines and the outline maps come from our own services. How does that then look? Let me just quickly show that to you. Well, now it's the small one again. Oh, it switched resolutions in the meantime. Well, the map quality is very bad because of the washed out thing. But what you basically get is you can choose some data. This is just a mock-up with a little data. So for example, you can use the, I don't know, the amount of inhabitants. Oh wait, just use the English one, of course. You choose some data from the statistical service, for example, the number of inhabitants, and it gets mapped per municipality, and it gets mapped as a proportional point symbol map. And these decisions, of course, are in that system. So the fact that it has to go to a particular service here, so it gets the data from the particular data service in the SDI, transfers it into a D3 map, puts it on top of the base map, and then you see the circles popping up. And you can actually see that the town of Enschede, where I come from here, has slightly over 150,000 people. And if you go to the, let's say, one of the densities, of course you get choropleth maps. You can also have, there's only at the moment only one type of chromatic map in there, so just all the municipalities. And the same you can do per province. This was just to test our aggregation service, so this is live aggregated from the services into provincial data. Because at the moment when we started this the Central Bureau of Statistics only had their municipal data out as open data. So we do it like that, population, etc., etc. Well, very simple interface, of course. I have to hurry a bit. So the idea was then to also have a version of this as a statistic dashboard, building further on the Atlas prototype. So this is basically already, in that sense, a statistic dashboard. If you just look at the statistics data in the SDI, you can look have all the standard statistical mapping that you can have from the statistical data available. We wanted to go a bit further, specifically for the statistical data from the Statistics Netherlands office, the CBS, Central Bureau of Statistics, because just recently they published that as open data, so not only some selected data, but all of their data is now available through an API using the OData standard. And so you could actually get much more detailed data up to the level of neighborhoods, and you can actually get exactly also of larger time spans, etc., etc. They have a small thing themselves, but here you can also only use their own data, and it's a very traditional map, which they themselves say, well, they used an engine that they still had, we're not very satisfied with, and we wanted to actually concentrate here on the comparison tools. So there was we started a project with them, and unfortunately, as I said, the funding for that fell through, so we didn't get much further than the thinking about it stage, still hoping to go ahead with it in the future. But the idea there is to concentrate then much more on comparison tools, which are not in the current Atlas. So comparing things in space, so having the same variable in different places, for different places, so you can have the same variable, of course, at different aggregation levels. You can also compare in time, because they have the data for a long time series. So you can also, of course, have variations or comparisons in theme. So you could have the same place and time with different variables. I don't know, the occurrence of ticks in the woods. That should come from another data site, actually. Ticks are the little animals that can bite you. And the CBS has data about the Lyme disease occurrence. That is a disease you can get from these tick bites. And this is an interesting thing to compare, of course, coming from two different data sources. And that would also be a nice one. What you need, of course, there is, again, this editorial. So the idea of that is that you have a slightly more involved user interface than the one we have. So basically what you do now already have is that you want to make a map, you choose a subject trees comes up from the different sources, and you choose, for example, population density per province, and you can then just map that in the simple renderer, and the map comes out. Then there should be the possibility to say, well, I want to now compare that with, and then you choose another subject, and you can compare it in different ways. Just a simple side-by-side map. Other things I will show some mock-ups of after this. But the core important thing being that, of course, this choosing of subject and this comparing with another subject are very closely linked, and there should be this editorial influence, the cartographer's mind, or whatever you want to call that, which tells the system, well, if you have this particular subject, there's an interesting comparison to be made with those things, but there's no comparison possible because of certain reasons with those and other variables, because they're not, shouldn't be matched or compared because of all kinds of different reasons, different time spans, different aggregation levels, etc., etc. Now you could, of course, just have side-by-side comparisons. This is two of them I took out of the amount of non-Western foreigners per municipality and the amount of Western foreigners. So in the Netherlands you have quite a lot of people on the border with Germany and Belgium, which that live in the Netherlands and work in the neighboring country, or the other way around. Actually, also, while the non-Western foreigners are more concentrated in the main cities. These are the bigger cities especially here in the Randstad, in the Holland part. This is, of course, nice to compare side by side, but you could also want to do that as a sort of a swipe, where you can have them overlapped, and then you can swipe through the different maps like that, or even as an overlay, a transparent overlay, which doesn't at all work at this website thing, but you can still see that, if you go back and forth, the one takes over the other. So there are very many possibilities. Unfortunately, as I said, we didn't go much farther than the conceptual stage at this, so that's all I have to I'm able to show you at the moment. We're certainly hoping to go further with this. The National Atlas as an experiment is still continuing anyway, and we are using that same system. Thank you very much.
Thank you, Alan. It's a pity we didn't have more time to give your view on this. Are there any questions on the idea of the dashboard?
I was interested in perhaps the approach that you take with separating your data from the maps, these sort of overlaying the data onto maps. When, particularly with geographical regions, the underlying map can change. So, for example, if we were looking at the nationalities of people in the Crimean Peninsula recently, are they Russian, are they Ukrainian? If your underlying data set is registering their nationality and that's used as their location, that would often be a problem. Would you, do you then have a suggestion or approach that you take that those underlying data sets that you're receiving should, instead of specifying a nation that an individual might belong to, should suggest a geographic specification as to where they're located? How do you tackle that problem?
Yeah, well, we don't have that problem. Well, I didn't see maybe the Belgians will come and take Limburg off our hands, but no. Well, the challenge here is not so much how you would want that to be, because in many ways you can't influence it, because the data we take now, for example, from the Central Bureau of Statistics, just has a certain way of doing that. And actually, what we do in the current prototype of the Atlas is we take their data, which is GeoJSON data, which has the borders of the municipalities and their coding, plus the variables in there. What we actually would want to do, and we are wanting to do that in the cartographic dashboard, is now that they have separated that themselves, they offer the actual attribute data, so just the tables also, with a code for each municipality, to see how you can go about extracting that data, coupling it with your own municipal data borders, for example. Actually, the municipal data borders are a good example, because the originating office for the municipal boundaries is the topographical office, not the Central Bureau of Statistics. So they actually take that from the topographic office, generalize it in quite a heavy generalization, and then use that in their maps. And it would, the first experiment we would want to do is to use the original municipal data, border data, and then use the attributes to map it on top. When it becomes interesting is a bit like your problem, is that these in the Netherlands these municipalities change quite a bit. They merge and they, yeah, right. So making time series or getting data from the different times, it would be very nice to see how you can figure out this municipal codes, which are coded quite cleverly to always point to one specific municipality at a specific time, and to find a mechanism to get the correct municipal boundaries with that. And that in some way could solve also problems. If Limburg then becomes Belgium, well, it should still be traceable through the system. But what it also does show you is that we are not striving to do this fully automatically, in the sense that let the system figure out what is possible and what is not possible. There will always be this core metadata, in our view, which is basically the editorial heart of the atlas, which is saying, well, this is the kind of things we figure our users are needing or wanting and should be seeing, and some other things are just not possible for the reasons like that, or for reasons of this being a nonsensical thing to compare and the thing. So there is, in our view anyway, always an editorial step where you decide what to put and what not to put in the atlas, because in our minds an atlas is just that. It's more than just a collection of data. It's a collection of data which you present with a certain idea and with a certain thought behind.